Hey everyone, welcome to my video on the thyroid. We are going to be going through a couple different feedback loops besides just the thyroid one. So as we're going through our notes, check to see that you know where to put the feedback loop for TSH, or the thyroid stimulating hormone. We're also going to be talking about calcitonin and the parathyroid hormone. So just look through your book to find those three. The drawing quiz will be on the three, but we're going to kind of take a day before we do the drawing quiz. So drawing quiz will not be Monday. It'll most likely be Tuesday, just to kind of talk about these, as the three of them can be a bit confusing. So the thyroid. Let's talk a little bit about the thyroid. I think the thyroid is one of the most interesting glands in your body, simply because it is a gland that actually influences every single cell in your body. Okay. Thyroid hormones regulate your metabolism, so the metabolic functions in your body. So your thyroid actually stimulates all the tissues in your body to produce proteins and increase availability of oxygen to your cells. So that's a huge thing. This tiny gland at the front of your throat does this massive thing throughout your body. Okay. It also kind of acts as like your furnace. So when you get cold, the pituitary gland says, hey, thyroid, turn on. The thyroid turns on and it produces some TSH, which kind of warms you up. And then it goes back into not producing the TSH, and then you can cool down. So again, that's also part of a feedback loop. Okay. So like I said, I find the thyroid extremely interesting. We're going to talk about T4 and T3 as part of the thyroid, just two of the types of thyroxine. And what is kind of also interesting about it is that the thyroid, because of the production of thyroxine, is actually very much linked to your liver. Okay, so that's kind of also an interesting thing. The T4 is converted into T3, which are the types of thyroxine in your liver. So that's kind of why they're so highly connected. So again, I digress a little bit. Like I said, I find the thyroid extremely interesting. We are going to talk about the thyroid's ability to also uptake iodine, because it becomes extremely important when we're talking about goiters. And we're also going to talk about how it connects to fetal development, which is also a huge thing. The fetus actually starts producing thyroxine. So the gland itself, the thyroid gland, produces thyroxine starting at 18 weeks of gestation, which is huge. And if a thyroid gland isn't actually working, you have huge problems in the development of the fetus. So again, digressing, just love the thyroid. Think it is a super cool gland. So again, we're going to talk about this beautiful gland. We're also going to talk about the four glands that are attached to the front of it, called the parathyroid glands. And we're going to talk about thyroxine in regards to the thyroid gland, and calcitonin and PTH, or the parathyroid hormone, in regards to the parathyroid glands. So again, here are our feedback loops. So let's talk thyroxine. Okay, let's talk the thyroid. So here is our negative feedback loop. All right, you can draw this in the box you have. You can also use it as the one in the back of your notes as well. But essentially, here's what's happening. The hypothalamus, again, releases this hormone called the thyroid releasing hormone right here. Please make sure you remember to label that in your feedback loops. Okay, when you're drawing it, it's really important, because again, the hypothalamus can't just trigger anything. It has to have some sort of way to talk to the anterior pituitary, and that released hormone is the thyroid releasing hormone. So the hypothalamus says to the anterior pituitary, hey, there's something going on. So the pituitary gland then produces some TSH and releases it to the thyroid gland. And again, like I said, the thyroid gland does metabolic functions, uptake of oxygen, help maintain fetal development, help you stay warm and stay cool. So it does a lot. So this TSH secreting to the thyroid gland has many different effects. Once the thyroid gland receives the TSH, okay, it then starts producing thyroxine. Now, as you can note on the side there, I said there's two types of thyroxine. There's T4 and T3. Both of them need iodine to produce. And again, we'll talk about why iodine is important. And the conversion of T4 to T3 is done in the liver, which I already said. Okay, but essentially T4 and T3 need iron, iodine. And if you don't have iodine in your body, you can't actually make thyroxine, which is bad, because again, the hormone thyroxine does so much. Okay. So once thyroxine starts to increase, like I said, a couple things can happen. Your body can heat up. Your metabolism will kick in. Your body will uptake oxygen a little bit better. Eventually, what's going to happen though is as thyroxine increases, your hypothalamus and your anterior pituitary are going to get the message, hey, we have enough thyroxine, stop producing it. And that's our negative feedback. Okay. Another good way to think about it is if you're thinking about the stimulus that happens. So whenever we've been drawing a feedback loop, we've said, here's balance and what is our stimulus? A lot of times the stimulus could be, for example, the decrease in metabolism, or I'm too cold, I need to warm up. All right. So if you want to draw it like we did in class, like insulin and all the other ones, you would just show off the balance. The balance is tipped, a decrease in metabolism, or you're too cold. And then you would say the hypothalamus talks to the anterior pituitary. They release TSH, which targets the thyroid gland, which increases metabolism, increases heat, increases oxygen uptake. All right. So that is thyroxine. That is the thyroid gland. That is how it actually functions. So the next thing we're going to talk about, or I'm going to talk about, and hopefully you get into your notes fairly quickly, is about these two called calcitonin and parathyroid hormone. Now, just like glucagon and insulin work to keep our blood sugar levels in balance and in homeostasis, calcitonin and parathyroid hormone do it for calcium. Okay, it adds calcium to our bones, or it removes calcium from our bones. So we're going to talk about the balance between those two. Again, my drawing is a little bit different. If you're not liking it, again, don't stress, put it in your notes. We are going to do some more drawing on Monday. So here is the two parts to calcitonin and the parathyroid. So in class, I always draw a balance. Here's our balance. Okay. If it tips and this side is too high, okay, so if our calcium levels rise to a point that is too much, okay, we have too much calcium in our blood, we need to get rid of it. That triggers our thyroid gland to release something called calcitonin, okay? Now, the way I like to remember calcitonin is that we deposit calcium into our bones. So the blood calcium level falls when calcitonin comes into play because we deposit it into our bones and teeth. So again, my little trick is rather than calling it calcitonin, I call it calcibone in, reminding myself that the calcium is going into the bone. So once calcitonin is released and removes the calcium from our blood, it then obviously decreases and goes back to homeostasis, to this balance. Now, sometimes what can happen though is we know calcium is extremely important for muscle contractions. And a lot of times in the sarcoplasmic reticulum where it is stored, we may not have enough. Okay, so we might need to uptake a little bit more calcium into our blood to circulate to our muscles. So what happens is sometimes our calcium levels are too low. What do we do if they fall too low? Well, if it falls too low, again, now we're looking at these little tiny glands called the parathyroid glands, okay? If calcium falls below a level that we need, the parathyroid glands release PTH, okay, or the parathyroid hormone. And the parathyroid hormones then go to our bones and it removes calcium from our bones. So when it removes calcium from our bones and teeth, it helps increase our blood calcium levels, and calcium can be transported to our muscles all around for us to use for muscle contractions. Again, once our calcium levels have risen back up, we remain back into homeostasis. All right. So those are the two different feedback loops. You could draw them as one if you like the way this looks, or you can again separate it into the two boxes into your notes. What I have here is just, again, that little trick to remember it, as well as kind of just showing you where is calcium going, okay? Where is it coming from and where is it going? So again, my trick to remember calcitonin is to put it into the bones, so we call it calcibone in. So this feedback loop right here is no different than the feedback loop I just spoke about. Rather than showing you the hormones, it's showing you where calcitonin is sending the calcium. Okay, so here it's showing we're increasing the calcium into our bone deposits, we're intaking it into our intestines, and we're decreasing it from being removed from our urine. So we're somehow excreting it in some form. Okay, When we have too little, the opposite is occurring. We take it out of our bones, we increase the uptake into our intestines, so then that way we can use it in as we absorb molecules and macromolecules. And then we also increase reabsorption from our urine. So by removing it from our urine, putting it back into our bloodstream, we can increase it that way. Okay. So again, this is just a way to see it in another form and where it's going and what's happening. So as a reminder, all three need to be in your notes. We are going to talk about the parathyroid and the thyroid on Monday. We're going to practice drawing these again. And then on Tuesday, you're going to have your drawing quiz on this as we move forward with another video. So just be prepared that 3 drawings are going to be Tuesday. And on Monday, we're going to do a lot of practice. So I hope you guys have a great weekend, and I will see you all on Monday.